In this video, we will look at how to calculate momentum. Use the idea of momentum to describe the movement of objects, and use the law of the conservation of momentum to describe momentum in elastic collisions. First, try this question. A car is moving along a straight road at a constant speed of 60 km per hour. The forward force from the engine is greater than, equal to, or less than the backward frictional forces. If you said greater than, you may be confusing force and momentum. The moving car has a forward momentum, defined by its mass times its velocity. But because it is not accelerating, its velocity is a constant 60 km per hour. The forces must be balanced, so there is no net force on the car. If the engine force were higher, the car would be getting faster, increasing its speed and momentum. And if lower, the car would experience a backward force and would be slowing down. So, momentum is a measure of how difficult it is to stop a moving object. The more massive it is and the faster it is moving, the harder it is to stop it. Think of firing a cannonball at a castle wall. If it were made of wood or traveling slowly, the wall can easily stop it. But if it is made of a dense metal and traveling fast, it could go right through the wall. So try this one. The car is slowing down. The arrow shows its velocity, which is getting lower. What direction is the net force on the car? Is it forward or backward? Yes, the force has to be against the forward motion to enable the car to slow down. And what about the momentum of the slowing down car? Yes, because the car is still moving forward, even though it is slowing down, it still has a forward momentum. All moving objects have momentum in the direction of movement. A stationary object has a momentum of 0. We calculate the momentum using this equation. Momentum is equal to mass times velocity. This can also be displayed in a formula triangle like this. So, mass is equal to momentum divided by velocity, and velocity is equal to momentum divided by mass. So what are the units of momentum? Mass is measured in kgs and velocity in meters per second. So momentum is equal to kg times meters per second. Now try this example. What is the momentum of a 2000 kilogram car traveling at 7 meters per second? Pause the video while you work it out. How about this one? A stationary car has a mass of 2500 kilograms. What is its momentum? Pause the video. The car is not moving, so its velocity is 0, and so it has no momentum. So what is the law of the conservation of momentum? In a closed system, the total momentum before an event is equal to the total momentum after an event. Let's look at how to apply this. Two cars of equal mass, 800 kilograms, collide. Before the collision, car B is at rest while car A is traveling at 15 meters per second. Calculate the momentum of car A. After the collision, the two cars are stuck together. Calculate the velocity of the cars after the collision. Pause the video while you work it out. How did you do? Let's try another. Two toy passenger cars moving towards each other collide and stick together. Use this information to calculate the momentum of the cars after the collision. Pause the video while you work it out. Note, because car B is moving in the opposite direction to car A, its velocity is negative. This means that the two cars are moving from left to right in the same direction as the car A. Even though the car B is more massive than car A, the velocity of A is much more than B. Let's finish with this toy. Can you explain why the end ball moves off at the same speed as the colliding one? And what if we pull 2 balls out and then 2 move away, conserving momentum? If 3 are pulled up, then 3 move away. A lovely illustration of the law of conservation of momentum.